Myself Indumati, Assistant Professor, Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Science, Vistas. Today in this session, we are going to see Friedel-Crafts acylation reaction. So, Friedel-Crafts acylation is nothing but a reaction which involves the addition of acyl group to the aromatic ring. So, generally this reaction is done by employing by the addition of acid chloride. To this we will add a Lewis acid catalyst, that is the aluminum chloride. So, in Friedel-Crafts reaction, the aromatic ring is transferred into a ketone molecule. As you can see the example here, this is a benzene structure. To the benzene, we are adding acyl chloride in the presence of aluminum chloride, AlCl3. What is happening means the hydrogen from this carbon reacts with this chlorine molecule and it liberates as a HCl and it leads to the formation of a substituted product. So, this benzene is converted into an aromatic ketone molecule. That is, this aromatic ring is converted into this ketone molecule. So, for this one, we are calling this reaction as a Friedel-Crafts acylation reaction. So, this Friedel-Crafts acylation reaction generally involves a three-step process. First step is the formation of acylinium ion, that is nothing but electrophilic, it's electrophile. Second step is the formation of the attack of electrophile, and third step is the loss of proton. So, in first step, the acyl halide react with the Lewis acid in the presence of aluminum chloride to form an acylium ion. So, this acylium ion undergoes an electrophilic attack on the aromatic ring to form an intermediate. So, from this intermediate, proton get lost and it leads to the formation of aromatic system and it lead to yield acylated product. So, this reaction is very important for all the reactions for adding acyl group to the aromatic compounds in the organic synthesis. So, as you can see the example or mechanism of reaction here, first we are taking an acyl chloride. To this acyl chloride, we are adding an aluminum chloride, AlCl3. So, what is going to happen is this Cl will react with this AlCl3 molecule and it liberates as AlCl4, and CH3 C double bond O plus will be liberated as a cation molecule. So, carbocation. This is an electrophile. This electrophile comes and attack the benzene moiety. So, what will happen? This benzene moiety attached to and it lead to the formation of intermediate. To this intermediate, again this AlCl4 reacts. The hydrogen from this benzene react with the AlCl4 and it leads to the formation of a substituted aromatic product. In third step, to this aromatic acyl group AlCl3, the chlorine from this AlCl3 molecule will react with the hydrogen and liberated as a HCl, and this AlCl3 get liberated and it leads to the formation of substituted product. So, what are all the limitations of Friedel-Crafts acylation means? Similar to alkylation, it also tends to fail on the aromatic ring with strongly deactivating groups like nitro group, sulfonyl group and so on. In halogenated aromatics, this Friedel-Crafts acylation still working. So, probably we don't need to know the category, but catalyst turnover in the Friedel-Crafts acylation isn't great. In real life, a stoichiometry amount of aluminum chloride is generally required since the aluminum chloride coordinates strongly to the ketone product. So, I hope you understood the concept of a Friedel-Crafts acylation reaction. If you have any clarification, please contact me. Thank you.